Assalamu alaikum wa rahmatullah, and good afternoon to all of our respected viewers on Voice of the Cape's Facebook page as well as the VOC's YouTube page. It gives me great honor and privilege once again to introduce our facilitator for today, that is none other than Brother Imaad Isaacs, the head of Futures Academy SA's online high school. And as a reminder, this is of course the Voice of the Cape's annual Matric revision program for this year 2023 in collaboration with Futures Academy SA Online High School. For those who tuned in yesterday, you will remember that Brother Imaad went through mathematics paper one, and he indicated that today, inshallah, will be the continuation of paper one for mathematics and the preparation for all of you, our matriculants. Of course, this program is dedicated to all of you, our beloved matriculants. And inshallah, we hope that each and every one will be successful as you embark upon your examination periods for the mock exams that are examinations, as well as for your NSC examinations that is to come at the end of the year, inshallah. Without further ado, we hand over immediately to Brother Imaad Isaacs. We'll continue from where he left off yesterday with the revision for mathematics paper one in preparation for the upcoming examinations for mathematics. Without further ado, we hand over to Brother Imaad, inshallah. Brother Imaad, inshallah, whenever you're ready, then you may commence, inshallah.
You Can you hear me? Amir, can
Loud
you
and
hear me?
clear, inshallah.
Okay,
Loud and clear.
awesome, awesome. Sorry, because I couldn't see the the green thing there, and something kicked me out and then brought me back. Okay, alhamdulillah. So we
No
are here.
worries. Bismillah.
So, inshallah, as mentioned, we are continuing with our section on functions. Yesterday, we covered quite a few things. We went over the 4 standard functions. We went over the types of functions and the manner in which they can be represented. Then we also went over the straight line, the quadratic, exponential, and hyperbola in terms of the general forms. We shifted them upwards and we also shifted them to the right. So you can see when shifting upwards, everything you see in red here, that's what's going to happen. And then for 4 units to the right, everything you see in terms of being adjusted with X, that's what we see over there. Then we also went over a little bit of function notation in terms of the reflections, how to read them. Here I've got an f of x function. I've got the same y output, but I've got a negative x as the input yielding the same output. And therefore, we say that's a reflection in the y-axis. We looked at what's a reflection in the x-axis. We looked at vertical shifts upwards and downwards. And then we also looked at horizontal shifts upwards and downwards. I apologize, left and right. Okay, and then we also sketched 2 functions where it was given in 2 different forms. We had f of x in the form of the vertex form or the turning point form. That's what it's sometimes referred to. And we also had f of x in terms of the standard form ax squared plus bx plus c. Now, today we're going to move on a little bit, and we want to, instead of sketching the function and using the properties that we have from there, we want to now find the equation. So instead of moving algebraically to a graphical representation, we want to move the other way. We want to go from a graphical representation, in other words, the graph is given, and then we want to sketch, we want to determine the equation. So graphical to algebraic expression. Okay, so let me just bring up our whiteboard quickly. Ooh, that never looks good. Let's click try again. Let's just see. But anyway, while I get the whiteboard to just resume over here, let's talk about the function that you see on screen, right? The function that you see on screen over here, that function, okay. It's loading the board content now. The function that we see over here, we clearly know it's a parabola. We can see it's a parabola. We can see it's a quadratic function based on its shape. We can also see we are given information. And the information that we are given over there, there's 2 parts to it. The one is we are given the turning point, that's 1 and minus 9. And then we are also given another point, right? So, okay, so here's our whiteboard. Let's bring that whiteboard back. Okay, and we want to find the equation of that particular function that we see over there. Okay, so let's do that. Now remember, you were given two general forms. The one was the turning point form, y is equal to a into x minus p all squared plus q. The other one was y is equal to ax squared plus bx plus c. Now remember, here you can immediately read off the turning point as the coordinates p and q. Okay, so what you want to do with that is you want to say, how can I actually find the equation of this graph? And now it's fairly simple, because when you have the equation, the only unknown must be x and y. So there's two things that we're going to do here. Number one, we're going to read off the turning point, which is 1 and minus 9. And then we're going to plug it in to the p, and we're going to plug it into the q, right? So that solves our issue of finding the p value and the q value in this form. Then we're sitting with an unknown here, which is the a value. Now that a value, how do I get it? What do I do? Well, I simply need to find something that I can throw in here that's going to solve for that a. And what I can put in will be this x and this y, which refers to an ordered pair. And therefore, if I'm given the turning point and at least one other point, I can easily find the equation of that straight line. Okay, so how do we do that? We're going to say y is equal to, what is the a value? Well, we don't know. That's what we're going to have to solve for. I've got x, that's a positive one. So here I must have minus 1 all squared plus negative 9. And if I add negative 9, I'm going to be left with minus 9. Okay, right. So now I'm still left with this unknown a. So half our job is done. We're not done yet. What do I do over here? Okay, I substitute in a point for x and y. That x and y must correspond to another point, any other point. And I'm going to select this point over here, which is minus 1 on the x and 0 on the y. So now we say 0 is equal to a multiplied by, oops, that minus 1 is not written there, so that's minus 1. Minus 1 all squared minus 9. Okay. And now if we solve for that, we can easily bring over that 9. And we can work out what this is. So that's going to be a 9 over there. And I'm left with a multiplied by minus 1. Minus 1 is minus 2. Minus 2, if we square that, I'm left with 4. So on this side, I'm left with 4a. And that 4a, if I divide both sides by 4, I'm going to sit with 9 over 4. Okay, so that's my a value. And 9 over 4 will simply be, what's 9 over 4? 9 over 4 is 2,25. Yeah. Okay, so that's going to be 2,25. So there's my a value. So the equation of this particular graph that you see over here will be y is equal to 9 over 4. That's my a value. X minus 1 all squared minus 9. Okay, and that's the equation. Right, 2 to 4 mark question, 2 to 3 mark question, fairly easy, substituting points, solving for a, writing out the final version of that. Again, relevant for grade 11 as well as grade 12. Okay, let's move to the next one. So if we are given the turning point and another point, two things we need to remember over here. Number one is that we can substitute in the turning point into the turning point form of that formula, and then we can substitute in the other point in order to get the a value over there. Okay, now what about the situation where we are given the x-intercepts and we are given another point, right? So let's look at this case over here. Let's look at this example over here. Just checking the battery. Okay, so what's happening? What's happening? What do we see over here? Well, once again, we've got a graph. We are finding the equation of this function that is given over here. And if we look fairly carefully, we can see what points we are given. We are given the two x-intercepts, and we're given another point, right? And it so happens that the other point is the y-intercept in this case. So what will that question look like? Well, what form can we use? So we have another form, which is the factored form of the quadratic equation, which is y is equal to a into x minus r1, sometimes referred to as x minus x1, and x minus r2, where r1 and r2 correspond to the roots, right? I'm going to put over there are the roots of the equation. The roots of the equation. Okay, so here the roots are given. The x value here is 1, and the x value over here is 3. And now you see this discussion we previously had about the minus r. It means if you saw minus 1 here, then you put there plus 1. If you see minus 3, then you're going to put there plus 3. In this case, you see plus 3, so here you must put minus 3. And here you see plus 1, so there you must put minus 1. Remember always what the negative x is. Negative x is always the additive inverse of x, which is always the opposite sign of whatever x will be. So how do we substitute in the points? We've seen that x is equal to 1 or x is equal to 3. We now plug it in and we can say x minus 1 and x minus 3, right? So now I say y is equal to a. Remember a is that factor minus 1 because I've got a positive root over there, multiplied by x minus 3. Okay, and what do I have over here? Y is equal to that thing, right? But I need to still solve for a. So how do I solve for a? I substitute in a value for x and y. And the values that I use for x and y, once again, comes from another point or point that I have. So here the point that I can see is 0 and 3. So 0 on the x, 3 on the y. That's going to be the point that I'm going to consider. And if I plug that in, the 0 there goes to x. The other 0 also goes to x. And the y value will be 3. Okay, and if we solve the next line, what does that look like? Well, I'm sitting with minus 1 and I'm sitting with minus 3, and minus 1 times minus 3 will give me positive 3. So, and minus 1 times minus 3, that gives me 3. All right, so this side I'm left with 3a. That 3 comes down, I divide both sides by 3, and I'm left with a is equal to 1. So my a value is 1, therefore, the equation that I'm going to sit with is y is equal to a, which is 1, you don't have to write it in, x minus 1, and x minus 3. That's my equation. Okay, at this point in time, if you feel like multiplying that out, you can also write it in standard form. That's going to give me x squared. That's going to give me plus 3. That's going to give me minus x minus 3. That's going to give me minus 4x, right, which we can put over there, minus 4x. So this is correct, and so is this. Okay, so there we've done two things. We found the equation of a parabola when we are given the function. In other words, we were given the graph. We now need to come up with the algebraic expression in terms of what that graph looks like. Okay. Okay, if there's any questions, feel free to ask, feel free to comment and send it in. Okay, now let's go into some exam questions, students. And we want to ease you into this, so we'll start off with, some of the easy things, right? 12 marks. Remember the ratio? 12 times 12 is 144, so 12 times 1.2 will be 14.4. And the ratio that you need to look at when in your examination, on average, is 1.2 marks for every minute, okay? 1.2 marks for every, one mark for every 1.2 minutes, right? Because a 50-mark test, you're given 60 minutes. So for this question of 12 marks, we will be awarded roughly 14.4 minutes to answer this question. Righto, so what will that look like? Okay, so question 7. Let's read the question that we have here. right? Sketched alongside are the graphs of f of x is equal to minus x plus 2 all squared plus 4 and g of x, which is equal to ax plus q. R is the turning point of f. Now, if we start 7.1, my apologies, if we start 7.1, before you even go over there, look at the standard forms of f and g, right? The f of x refers to the y values of the graph named f. The g of x refers to the y values of the graph named g. And if you look at the form of f of x, you can clearly see that this is in that form of ax minus p plus all squared plus q, and this is in the form of ax plus q. So you can see that this matches the form of a linear curve, and the other one is a parabolic curve. Then 7.1's question asks you to give the coordinates of r. Okay, give the coordinates of r. Now, if you look at where's r, they tell you what r is. R is the turning point of f. Now, where are you going to get that from? Well, you're going to tell me, Imaad, that's obvious. We just learned that. We went over the turning point form, and we can clearly see that the answer to that question of 7.1, we're going to read off straight from the formula. Okay, we're going to read it off straight from the formula. Why is it so hard getting that part there? This is a game we play with a mouse. There we go. Okay. So now, let's start with that first question. 7.1, we're going to give the coordinates of r. We're going to read it straight from there, 7.1. And 7.1, we can see that the turning point will be at minus 2. And it's going to be at positive 4. Now, minus 2 is on, and positive 4 is in the second quadrant. You can see the x value is negative here, and the y value is positive. So this will definitely be correct, and we can check our intuition there, okay? And you'll get, depending how the examiner has set up this question, it might be 1 mark, might be 2 marks. If it's 2 marks, they might sometimes break it up where they give you 1 mark for each coordinate. Okay, so we've read that directly from this. Okay, don't be confused by it. It's given just by looking at it over here. Then calculate the length of AB. AB, good question. Now, how do we calculate the length of AB? Well, one way to look at this is that if you look at R, you know, that R, if I look at a parabola, and this particular parabola is like that, I've got an axis of symmetry, and we can clearly see that this coordinate here is 0, right? 0 and 0, it goes through the origin. And then the line here is x is equal to negative 2, which means from this point to this point, if I look at symmetry over here, from that point to that point, I'm sitting with 2 units, right? Because if I go from 0 to negative 2, I look at what's known as the absolute value, the distance from 0 to that number on the number line, and the distance from 0 to the number negative 2 on the x-axis will be 2 units, which means that this length AB over here is going to be 2 units plus another 2 units, and therefore the answer for 7.2 will be 4 units, right? And how did you come across that? You can say symmetry, right? We can say by symmetry, in case the examiner thinks you're cheating or copied another student's work. Okay. Let's go further. 7.3. What's the other way you could have done that? The other way is to take the equation, because the entire equation is given, and we can say, before we continue, let's see another way of solving 7.2. Alternatively, we've got minus x plus 2 all squared plus 4, and that's y is equal to that, but we can solve the roots, right? And how do we solve the roots? We make that whole thing equal to 0, right? And if you make that equal to 0, you will be left with x plus 2 all squared is equal to 4, right? So I'm just taking this whole term to the other side, which in this case I've written it on this side. And multiply this out. And I'm left with x squared plus 4x plus 4. And that's, you see, this will be plus 4 is equal to 4. And the 4's and 4's cancels out. So now I'm left with x into x plus 4 is equal to 0. Therefore, x is equal to 0 or x equals negative 4. So which means the coordinates, ooh, what is that? The coordinates will be minus 4, will be minus 4 for B, right? So B will have a point over here, and B's point will be minus 4 and 0. So if we take that as minus 4 and 0, then the distance from 0 all the way to minus 4 will be 4 units. Okay, so there's two ways of obviously solving that. You could have looked at the roots, at the x-intercepts, and then check the distance across that, or you could have easily just look at symmetry because you were given the turning point. And this helps you because you are given the you were given a scaffolded question. In other words, they asked you for the turning point first. Okay, let's go to 7.3 quickly. If we look at question 7.3, it says determine the equation of G. Okay, determine the equation of G. Now, if you look at G, let's go to the more standard way of finding the equation of G. You're already given ax plus q. You could have said it's y equals mx plus c. It's exactly y is equal to ax plus q. Same thing, right? The m has been replaced with a and the c has been replaced with q. Now, students, you know that to find the equation of a straight line, I must have the gradient, which is this little a, and I must have the y-intercept. Okay, now here I've got the y-intercept. The y-intercept is actually 0, because if I take this line, this G line, it touches the y-axis at the origin. So the y-intercept, the c value, is actually 0. Okay, I'll put that down. Y-intercept, c is equal to 0, right? Or q is equal to 0. C equals q equals 0. Now you need the gradient. Now, two ways to find the gradient. You look at the points. The point R is going to be, we said, minus 2 and positive 4. So the one point is minus 2 and positive 4. The other point is 0 and 0. So the gradient of that line is to say m is equal to, let's just say this is x2 and y2, and this is x1 and y1. For the sake of revision, remember in the exam you don't have all the time to write this out, but the gradient is y2 minus y1 over x2 minus x1. And the gradient over there, I take 4 minus nothing over minus 2 minus nothing. That's 4 over negative 2, so I sit with a gradient of minus 2. Now, if I have to write out that equation, how do I write out that equation? It's fairly simple. Therefore, the equation will be y is equal to mx plus c. The m value is minus 2 times x. The c value is 0, so it's plus nothing, and that's my equation, right? Of course, you don't have to write in the 0 that you see over here. And then you're just left with y equals minus 2x. So guys, as you can see, functions are not really that complex, okay? Now, the next question, which is 7.4. In question 7.4, it's for some reason or the other, students are thrown off by function notation. There's no rocket science in 7.4. So in 7.4, let's see if we can make this a little bit thicker. In 7.4, they're asking you for which values of x is g of x greater than f of x. So what's the condition we're looking for here? G of x greater than f of x. For which values of x is g of x greater than f of x? And remember, this corresponds to the y values, and this also corresponds to the y values of f, right? This is the y values of g. Now, when we say one y, one of the values on the y-axis is greater than another value on the y-axis, that clearly just means you're looking for some y on top of another y, okay? So some y on top of another y. So I want you to look very carefully at this. To see if it's possible to make some annotations. Let's just see. Okay, forget that. Forget it for a moment. And there the annotations won't come. But nevertheless, let's just work with what we have here for a moment quickly. When we look at this question, right, the question wants to know where's the one graph greater than the other graph. So in terms of y values, if I had to just take it on a normal Cartesian plane and I ask you where's the one graph greater than the other graph, then all you can do is you can immediately tell me that anything above is greater than anything that is below it. So if this is y2 and this is y1, right? Then, of course, y2 is greater than y1. So here they ask you, where is g greater than f? So we're looking for all the places where the straight line, which is g, happens to be above the parabola. So where does the straight line go above the parabola? Here's the straight line. You see that? For everything on this side, right? That straight line that is laying over there and continuing, that straight line is above the parabola. But on the interval here, let's look at this interval here. Here I've got the parabola, okay? The parabola, which is blue, happens to be above the parabola. Oh, I didn't mean to do that. But the parabola here is above the straight line. But what we want is we want a straight line above the parabola, okay? So where is the straight line above the parabola? We must express this in terms of x. And when we express that in terms of x, the straight line above the parabola happens for all of the x values on this side, meaning the x is less than that coordinate, -2. And then here again, the straight line is here and the parabola is below it. Okay, so if you look at the blue graph over there, sorry guys, I know I'm messing here. I don't get to spend a lot of time with colors, so clearly I'm just messing, right? But here again, the straight line is above the parabola because here's my parabola, but here's the straight line. And here, it's all the values where x is greater than 0. Okay, so the one part was when x is less than -2, and on this part, it's x is greater than 0. So the answer to question 7.4 is 2 intervals. It's going to be x less than -2 or x greater than 0. Okay. Okay, 7.5. Now, here's those things that we went over, and when we looked at it very well. We said h of x is equal to f of -x. Now, I gave you some transformation rules yesterday, and I covered this very thoroughly. I've got some output of y. You have got the same y output. The only thing that changed was the input. The input became a -x, okay? And when x becomes negative, that's a reflection, i.e., a reflection in the y-axis. Okay, it's a reflection in the y-axis. So they say write on the axis of symmetry of h if h is a reflection of f in the y-axis. So in other words, the axis of symmetry, if it's on this side, that whole graph is going to flip to the opposite side. And that means the axis of symmetry, which used to be x equals -2, it's here x is equal to -2. The new axis of symmetry, which will have a new graph, which will be on this side, right? It will reflect across the y-axis, will be on this side over here. And that answer to 7.5, that's going to be x is equal to 2. because you just took the old axis of symmetry and you made it the opposite sign thereof, because that's what this notation means. Your coordinates went from x and y to negative x and the same y output. Okay, so the old axis of symmetry, x equaled -2. The new axis of symmetry will be then +2. Okay, now again, more function notation with some of that reflections that we saw on our screen yesterday. We've got p of x, and p of x is some manipulation of f of x. However, the x itself did not change, but f of x changed. It's no longer f of x. We now have negative f of x. And if we go to negative f of x, what did we have over there? We went over it. We covered it here. We said negative f of x. You used to have f of x. It's now negative f of x. That's a reflection in the x-axis. So when we reflect in the x-axis, right, that means that the graph is divided by the x-axis. Sorry, I'm just looking for my grapher that I want to bring on screen there quickly. So let's just take a parabola. And we take the same parabola just so that you guys can actually see this graphically. We've got negative x plus 2 all squared plus 4, negative x plus 2 all squared plus 4. Okay, so if we reflect in the x-axis, we take the same graph, okay, but now the same graph, but now the entire graph becomes negative because it's negative f of x, right? So that's exactly the same graph I have in blue, but I'm going to place a negative in front of it. I put it in brackets and you will know why, and that's my reflection. So if you look at the range of the red graph, the range of the red graph is everything is less than or equal to 4. And for the blue graph, everything is greater than or equal to -4. Okay, so you need to kind of understand what's happening here. When I had the original graph, it looked like that, and there was 4. The turning point there was because we've missed so much. Let's just take some of those things out. Okay, don't do that in your exam, right? I told you I'm just not accustomed to having so many toys in terms of colors, and so, you know, taking the opportunity here. But anyway, okay. So if we look at this point here, remember that that point there is -2 and +4. Now, when you reflect, remember this is a reflection in the x-axis, right? Why? Because the y became negative. Now, reflection in the x-axis, the new point on the new graph, even if you didn't know the graph looks like this, you must remember the turning point is relevant to the range. The new graph will still have -2 because nothing changes with respect to the x value, but a reflection in the x-axis will cause the y value to be negative, right? So whatever it was here, it's going to be the opposite. And since this graph now is concave up, the range here is greater than. The answer to 7.6 is y must be greater than or equal to -4, okay? Now, strictly speaking, when you write this out, examiners will give you full marks when you write like that in the NSC because you assume you're only working with real numbers. However, it is more appropriate to indicate that the y is also an element of the reals. Okay. So that was quite a bit. I don't know if we took 14 minutes, but of course we were explaining some things as well. Let's go to the next question. We've got about 16 minutes remaining for the broadcast. Let's see what we can do next. Okay, so here we've given you another question involving a straight line and a parabola. Now, I have not done any hyperbolas, although I will highly recommend you study hyperbolas thoroughly. There's always a hyperbola question in the examination, and when that question comes in, it's usually something fairly simple that everybody can understand. Okay. Okay, so here's our question 3. Let's read the question quickly. The functions negative x squared plus 2x plus 3, once again, you see that's in the form of a parabola, and g of x equals mx plus c. The equation is not given or drawn, with g passing through E, C, and A. A and B are the x-intercepts of, that should be the graph of f, I apologize, and CD is the axis of symmetry of f. So CD is the axis of symmetry. That also means that the coordinate C is the turning point, right? It's the turning point. Now, they didn't tell you that, but you should know it if they gave you that the line CD is the axis of symmetry. E is the y-intercept of G. So E is the y-intercept of G. Okay, great. Question 3.1 for 3 marks asks you to determine the coordinates of C, which is the turning point of a graph of F. Now, depending on the form it was given in the form of minus x squared minus 2x plus 3 in standard form. So in that standard form, ladies and gentlemen, we need to use what we learned yesterday, right? So for 3.1, so let's just put that there, 3.1, you need to use that the turning point occurs at minus b over 2a, and the y-coordinate is f of minus b over 2a. In other words, whatever value you find for minus b over 2a, you substitute it into f, and then you get out some y value. So let's put that in. What's minus b over 2a? It's going to be minus 2 over 2 times negative 1. Okay, and then we need to find the y value. So if we look at that, what does that simplify to? That's going to be positive divided by negative. The final answer there will be negative. And 2 divided by 2 is just 1, so that's going to be negative 1. Okay, then we need to solve the y value. So to solve the y value, we will substitute y is equal to minus 1 all squared minus 2 times minus 1 plus 3. What I've done over here is I've just plugged in minus 1. Okay, and when I work that out, what do I get? Minus 1 all squared is 1 times minus 1 is minus 1. Minus 1 plus 2 plus 3 is 5. 5 minus 1, that gives us 4. So the answer to this part here is 4, because when you work that out, that's 4. Okay? So how does the marks get broken up here? Well, you're going to get a mark for this, the axis, using minus b over 2a, solving it, and then 4, back substituting in the final mark over there. What about question 3.2? Determine the coordinates of a and b. Well, I mean, not rocket science, and this question even helped you. It said that a and b are the x-intercepts of f, right? So they're actually telling you, when you see x-intercepts, even if they didn't tell you here and they showed you a and b, you can see it's the x-intercepts. And when the x-intercepts are there, y is equal to 0. So to find the x-intercepts, we say 0 equals minus x squared minus 2x plus 3. Factors of 3, we add to give us that. But let's just turn the signs around. So I'm left with x squared plus 2x minus 3. Factors of 3 I subtract to give me, factors of 3 I subtract to give me 2. That's going to be x and x, 3 and 1, and that's going to be plus 3 minus 1. Therefore, the x values is x is equal to 1 or x equals negative 3. Always check your intuition to see that at least the quadrants are correct, and then also check if they say determine the coordinates of a and b, right? So when they say determine the coordinates of a and b, once again, you should get full marks there, but stated as a coordinate. So the a coordinate is going to be the positive x value, which will be 1 and 0, and the b value will be negative 3 and 0. Okay, negative 3 and 0. There we go. Okay, what's our next question? Let's see the next question. Write down the coordinates of the y-intercept of the graph of f. Well, keywords, once again, students, it says write down. That means that there's no brain work really involved there. So for question 3.3, if you go to your equation, remember for the y-intercept of a graph, we make x naught. So if I just cut that out, I'm left with only 3. So the y-intercept will be 0 on the x and 3 on the y. Okay, for 1 mark. Easy peasy. Okay, now question 3.4, if we are guided by the mark allocation, it says 3.4, calculate the length of CE. Now, when we're looking at 3.4 and it says calculate the length of CE, and for 6 marks, now remember 6 marks is roughly 4% of your examination paper. 4% of that question paper, right? What can we do at this point? Well, what can we do? When we look at it and it says 6 marks, 4% of the question paper, that tells us that there might be a little bit of work involved. So where's CE? Well, okay, E is the y-intercept of the graph of G. C we know is the turning point, and C's coordinates we already know, and that's going to be -1 and 4. Okay, so we need to get that distance between it. Okay, now in order to do that, I don't know if you can see another way, but at this point I think you need to find the coordinates of E and then apply your distance formula. Okay, so how do we do that? Let's write down the coordinates of C. So 3.4, coordinates of C was -1 and 4, I believe. Now we need to find the coordinates of E. But to get the coordinates of E, we need to find the equation of G. Okay, so equation of G, right? And how do we get the equation of G? Let's see. You need to find the gradient of that line. So we can take the gradient using C and A because those things pass through that, and then we can substitute 1 point in there. So let's do that quickly. Y is equal to mx plus c. The m value is equal to, what was the coordinates? My apologies, guys. What was the coordinates of A? A was 1 and 0, and C was right. So y2, so that's 4 minus nothing. So that's going to be just 4 divided by -1 minus 1. So that's going to be 4 over -2. And that gradient, what am I doing wrong? Let's just see quickly. Let's just find this here. Sorry, guys. Let's just see where we are. We have ACE, or points on the straight line. We need to take the gradient of this line, which is going to be the y coordinate, which is 4, and that's fine because the y here is nothing. And then the x coordinate is -1. My apologies. There, I see it now. Here's our error. Our error is this was the coordinates of B, and this was the coordinates of A, because A was that -1. Okay, so A was -3 and 0. So now things make sense. And this is an important thing to also think about. I started calculating the gradient here, and when I calculated the gradient, I said 4 over -2 gives me -2. But then when I looked at the graph, I said mentally, I didn't say this out loud at the time, is that's a positive slope. So what did I do that yielded a negative slope? And I used the wrong point because of my labeling in the previous question. Okay, so what we should have done, once again, it's still 4 because 4 minus 0 gives me 4. But I'm now taking the other coordinate, which is -1 minus -3. So -1 minus -3. And then obviously that's 3 minus 1, which is 2. So that's 4 over 2. And therefore my gradient is equal to 2. Okay. So now we need to find the value of C. So I'll have y is equal to 2x plus c. We solve for c by substituting a point on the line, and clearly one of the points is -3 and 0. So I'll have 0 over there, and I'll have 2 times -3 plus c, and therefore c is equal to, take that over, it's going to be +6. And that leaves us with the equation of the line y is equal to 2x plus 6. Okay, so something to take away from that is, yeah, that was the equation of the line. So substitution, value of the gradient, equation of the line. So now we're not done. The equation of the line that's half the marks. The equation of the line tells us that coordinate for E, the points for E, because it's the y-intercept, it's 0 and the x and +6. Now you can go to your distance formula, right? And the distance formula is what? Let's just make this x2, y2, and make this x1, y1. Okay, we've got about 4 minutes before the load shedding hits us. Let's just try and finish this question quickly. CE will equal to, you don't have to write out the full formula, but we'll write it out. Y2 minus y1 all squared plus x2 minus x1 all squared. And if we substitute those values in, I'm left with 6 minus 4 all squared plus 0 minus -1 all squared. That's going to be 2. 2 squared is 4. It's going to be 1. 1 squared is 1. So it's going to be the square root of 5. Okay, and that's the length of CE. Now there was one last question. Determine the equation of g to the -1 in the form of y equals. We can actually finish that. Now I haven't covered inverses in detail, and I think we must spend some time on that in the future. But 3.1 asks us to find g to the -1 of x. Now what is this? This is the inverse. And when they tell you find it in the form of y equals, or that thing is equal to, then you just follow your 3 steps. Now the 3 steps are, what are the 3 steps to find the equation of an inverse algebraically? Number 1 is you write down the original function, okay, which is f of x. Number 2 is you swap x and y. And number 3 is solve for y. Okay, so let's do that quickly. So we say g of x, I'll list it like that, right? So for g of x, I have y is equal to 2x plus 6. That's step 1, right? Then for step 2, I swap x and y, and I say x is equal to 2y plus 6 for step, and this is now g to the -1. This is already the inverse function, okay? But I must write it in the form y equals. So now I solve. I say x minus 6 divided by 2 is equal to y. And if you are told to write it in this form, then you swap the y and you just make it g to the -1 of x is equal to x minus 6 all over 2. Okay. Of course, you can obviously simplify that, right? So that's x over 2 minus 6 over 3, which is x over 2 minus 3. Okay, ladies and gentlemen, that brings us to the end of that question. There is one more question, which we'll just bring up on screen. There's one more question that we'll paste up here on the screen. And if you're working through the video, you can easily just press pause. And then it would be a good idea to work through this question 4, which has a hyperbola and an exponential graph. We will definitely continue with this particular question in the next session, which will be half of the session, and then we will move on to some of the things related to calculus, as well as other important considerations in the section on functions. Ladies and gentlemen, that brings us to the end of today's lesson. Thank you for your time, and I hand over to our brother Amir just before the load shedding hits us back in the studio.
Indeed, we say shukran, jazakallah khair. Thank you very much to Brother Imaad Isaacs for facilitating today's program. And we hope that each and every one of you who are preparing, all our matriculants out there who are preparing for your examinations, will find these sessions fruitful as you prepare to study and embark upon practicing for your mathematics examination in particular. We wish you each and everyone all of the very best. And once again, we say shukran. Thank you very much, Brother Imaad, for beautifully conducting today's session for the revision for paper 1 mathematics. And of course, we will take up the rest of the sessions in the coming days, inshallah. Thank you very much to all of you, our respected viewers, for tuning in. And just as a reminder, once again, please, for those who are in Matric, please send this link of the VOC's Facebook page and YouTube page to all of your friends out there who are preparing for the mathematics examinations in order that they may be successful in the exam preparations, inshallah. From our side, we say thank you very much. And until tomorrow, inshallah, when we continue with our next session, we say to you, Assalamu alaikum wa rahmatullah, and all of the very best.